All right, we're going to go over 10.3, which is vectors, part one. We're going to do this in two parts. And the first essential question is, what is a vector? Well, let's look at some of the definitions and some of the terminology, vocabulary that we need to know about a vector. So let's look at that. Well, the first thing is, what is a vector and how is it written? Well, a vector is written in the form of a letter, and on top of the letter, you're going to see an arrow. That's how you know it's describing a vector. A vector is going to have both a direction and a magnitude. Well, let's look at what those are. Now, before I get started with that, a vector is going to have a component form. And a component form is given by the coordinates that describe the horizontal and vertical change. Well, think of it as the slope. The vector has an initial point, which means it has a vertical change and a horizontal change. So again, has a vertical change and a horizontal change, kind of like slope. And it's going to be written in the form of x comma y, but notice the difference. It is not using parentheses. Do not confuse this with x comma y. X comma y with parentheses describes a location, a point that does not move. A component form describes the vertical and horizontal change. So basically the difference of the horizontal axis and the difference of the horizontal of the vertical axis. Okay. Now that we know that, well, what is direction and what is magnitude? Well, the direction is going to be measured from your initial point to the terminal point, and it's going to be given usually in the form of an angle, degrees. So basically your direction would be measured from here to here. And we would have to find the angle of that to find the direction. Now the magnitude is given by the length of the vector, and it's usually going to be written in the form of the absolute value of the vector, basically this form right here. And well, what would that look like? Well, the length would be starting from your initial point all the way to your final point. And I'm looking for the length, which is why it's written in the form of absolute value, because it should always be positive. So again, direction is the angle in which your vector is moving towards. The magnitude is the actual length of the vector. Okay, now that we know that, let's go ahead and look at the second essential question. And the second essential question is, how do you write the component form of a vector? All right, well, let's look at this example. And this is one of the perfect examples for vectors. So a plane is flying due north, but is pushed off course by a crosswind blowing east. Okay, so we know that this plane is flying north and it's being pushed off by wind to the east. At 1 p.m., the plane is at the point 10,10, so that it's its initial location. And at 2 p.m., the plane is at 100,410, which is now after it got pushed off by the wind. All right. Well, the first thing before I answer 1 and 2, I need to write this as a component form. Actually, we'll wait for the component form, but I need to find the speed of the wind and I need to find the speed of the plane in order to find the component form. Well, that would be your vertical and horizontal change. This is my starting location. I'm going to have a vertical change and I'm going to have a horizontal change. All I got to know is which one is which one is the wind and which one is the speed. Well, we know that the plane is going north, which means that the vertical change has to be the speed of the plane. Which means that the wind, since it's blowing east, that would be the horizontal change. All right. Well, how would we calculate that? All we got to do is find the difference, meaning take one of the, if you're finding the vertical change, you're going to take the y values and find the difference of those two. If you're finding the horizontal change, you're going to take the x values and find the difference of those. Well, let's go ahead and do that right now. What is the speed of the wind? Well, that is going to be 100. Again, my x values minus the other x value. So that would be 100 minus 10, which is 90, which means that the speed of the wind is 90 miles per hour. Now, what is the speed of the plane? Well, the speed of the plane is going to be the difference, or the vertical difference, which is the y values. So that is going to be 410 minus 10, which is 400 miles per hour. So that is going to give me the component form. The component form is x, which is the vertical difference or the horizontal difference, comma, y, which is the vertical difference. So this is going to be 90, comma, 400. That would be the component form. And before you switch to the next page, again, think about what is the component, how is the component form different from the standard coordinate pair? We're going to continue with the next essential question, which is pretty much the most difficult to answer. So how do you find the magnitude of a vector? So we're going to be looking for the direction and the magnitude. So let's look at the same example. And as you can see, I already have everything ready. So how can you describe the direction of the plane? Remember that the direction of the plane is the angle from the starting point. Well, that would be this angle right here, which I'm gonna call theta. All right, well, how can we find that angle? And if you remember back from geometry, we got SOHCAHTOA, which is gonna show us how to find the angle. All right, so which one do we use? Well, based on the angle, this would be opposite, adjacent, and hypotenuse. So we're gonna use the one that has adjacent and opposite, which is tangent right here. So that means that, oops. That means that tangent theta is equal to opposite over adjacent. Well, let's go ahead and plug in everything that we need. So that is tangent of theta equals opposite, which is 90, divided by adjacent, which is 400. All right, so how do we solve this equation? Well, we got to do the opposite of tangent, and that would be inverse tangent. So that would be inverse tangent. So that cancels, and we got to do it to the other side, inverse tangent. So this equals to theta equals the inverse tangent of 90 over 400. We're going to put that into the calculator, and we get 12.7 degrees, which means that the direction of my plane is 12.7 degrees. So it's going 12.7 degrees northeast. Perfect. All right. Well, now, how fast is the plane moving? Now I am looking for the length, which is from here to my endpoint. Now I'm looking for the length. Well, how can we find this? We can find this by using the distance formula. And the distance formula is going to be, and again, I'm looking from, this is my A, this is my C. So I'm looking for the distance of this vector. And the distance formula is the square root of x of 2 minus x of 1 square plus y sub 2 minus y sub 1 squared. So all you got to do is plug in the values and let's see what we get. All right, now that we plugged in our x's and y's, all we got to do is simplify this. So let's see what we get. Well, for the first one, we get 100 minus 10, which is 90. So that's going to be 90 squared plus 410 minus 10, which is 400 squared. Once we calculate that, and we can just put that in the calculator, we get 410, which is 410 miles per hour, which means that this is 410 miles per hour. So we can conclude that the plane is traveling 12.7 degrees east of north at a speed of 410. Oops, that's not what I meant to write. There we go, 410 miles per hour.